All right, class. Welcome to our last lesson of the module, the 5.2c lesson, volume of spheres. Let's get started. So it says, if a cylinder and a sphere have the same radius and the height of the cylinder is twice the length of its radius, predict what fraction of the cylinder's volume would equal the volume of the sphere. Okay, so this is a good introductory question. Let's go ahead and remind ourselves on the volume of a cylinder. We know that a cylinder is really just kind of like you have to find the area of the circle first, which is going to be pi r squared, and then you multiply it by the height, which is h. Right? That's just a recap of 5.2a. 5.2b, we learned about the volume of a cone. So the question really is asking, what would happen? How much of the cylinder would be? How much of the volume of the cylinder would be taken up if the actual the cylinder had a height that was twice the radius? So let's just use an example, like let's say r is equal to 3 or something like that. And let's just say that we had a cylinder that looked like this with an r of 3. And the height of the cylinder is twice the length of its radius. So let's go ahead and make the height. And I'm going to try my best to make this semi-accurate. Let's say that was 3. Let's make that one more time. Now that's going to be our cylinder. And we know that, let's say if the height was 6, right, the current cylinder's volume would be simple, right? We just do pi times 3 squared times 6. Now, the question really is, okay, well, we could find the volume of the cylinder, but if we had a sphere that was totally inside this cylinder, fully fitting to the very top, obviously there are some parts of the sphere that are not, like, we can see that the cylinder is larger than the sphere's volume, but let's say that the sphere had a radius of 3. Right. We know that a sphere by definition, now this is not a perfect circle, but a sphere by definition has the same distance from the center of the sphere all throughout the circle, right? The sphere, the three-dimensional object. So the radius of 3 here would also give you a height, an overall height for the sphere should be 6 as well. You can see in my picture, right? The radius of 3 gives a height of 6 for the overall sphere. The question is, how much of the cylinder is taken up by a sphere that fits directly inside that cylinder? Right? Does anybody have a guess? Well, maybe we don't know, but how about let's now take a look at a hemisphere, right? And if we were in class, I would draw this, but let's take a look at, let's say a hemisphere fits in the same kind of cylinder that we're talking about, and a hemisphere is just half of a sphere, right? And let's say we had a hemisphere that kind of touched the center of that cylinder, and it also had the same exact radius of 3, right? How much do you think this hemisphere would take up of this half cylinder, right? The cylinder that only has a height of 3. We don't really know. We can't really tell, but do you have a guess? Okay, so I'm going to go ahead and tell you, if this cylinder this cylinder would have had pi r squared h, which would have been pi times 3 squared times 3. And this would have been, what, 27 pi units cubed. Whereas the sphere, the hemisphere, is actually exactly, let me write this down, hemisphere is going to be exactly 2/3 pi r cubed. You can see how we got that, right? It's because the hemisphere is exactly 2/3 the same volume of the cylinder. So if I plug in 3, I get 2/3 pi times 3 cubed, which is exactly 2/3 pi times 27, which ends up being 18 pi units cubed. Okay. So in conclusion, a hemisphere, the formula for the volume of a hemisphere is going to be 2/3 pi r cubed. This picture is just trying to show you that it's 2/3 of the cylinder of the same radius and height. And when you double it and you make it a full sphere, that tells you that if a hemisphere is 2/3 pi r cubed, a full sphere, the formula would be 4/3 pi r cubed. This is a little bit of just a little bit of a proof. Obviously, I had to give you this concept that the hemisphere is 2/3 the volume of a cylinder. And if you know that, then you know that a full sphere is going to be 4/3 pi r cubed. Okay. Obviously, I know you may have questions on that, so let's just write this down one more time. Write down the equation for the volume of a cylinder where the height is twice the length of the radius, or 2r. So if h is equal to 2r, then technically the volume, right, the volume of this cylinder would be pi r squared times 2r, right? Because we said that the height is 2, the height is 2 of the radius. Right, so let's go radius, and this is 2r, and this is r. So then this volume of the cylinder would technically be 2 times r cubed times pi, which is 2 pi r cubed. And that would be the whole cylinder, right? We know that this, if we had, again, I'm going to draw this one more time, but if I had a cylinder with the sphere inside of it, we know that the sphere wouldn't fill up the entire cylinder, right? It would fill up a large portion of it, but it wouldn't fill up the entire cylinder. And again, as we said in the previous page, the volume of a sphere is going to be close to 2 pi r cubed, but it's not quite. It's about 2/3 of it. So you'd have to hit 2/3 time of the cylinder. And if you want to do 2/3 times the cylinder, it would be 2/3 times 2 pi r cubed, which ends up giving us the entire formula that is 4/3 pi r cubed. This is the formula for the volume of a sphere. Right, the volume of a sphere is 2/3 the volume of a cylinder with the height being 2r. Now, the height needs to be 2r because If the height is not 2r, then the sphere and the cylinder will not have the same height, right? A sphere's height is always going to be 2r. If you think about it, a sphere is a circle and the radius is r, so the height of the sphere is always the diameter, which is 2r. Okay, so it says if a cone, a sphere, and a cylinder have the same radius, and the height of the cylinder is twice the length of its radius, again, how does the volume of the cone and the sphere relate to one another? Wow. Okay, so this is where I could show you a video, and I probably will show you a video, but it's like saying we know that a cone is 1/3 pi r squared h, which is literally 1/3 of a cylinder, right? The cylinder is pi r squared h. And now we just learned that a sphere, if they all have the same height, which we're assuming they do, a sphere is going to be 2/3 pi r squared h, or pi r cubed. Pi r squared h, I'll just write h. But it's about 2/3 of that cylinder. So they're all kind of like in thirds, which is interesting. Okay, that was a lot of proof. That was a lot of just showing you why the formula exists that way. But what I really want you to know is just I want you to remember that this is the formula for the volume of a sphere, which simplifies to 4/3 pi r cubed. That's the formula that you have to remember. Okay, 4/3 pi r cubed. Okay, so then once you know that, plugging in the formula for like something like number 4 is decently easy. All you have to do is just go 4/3 times 3.14. That's what you should type into the calculator, times 5 cubed, which is going to equal, and you want to round to the nearest tenths. 5 cubed is 125 times 4 divided by 3 times 3.14. I'm getting 523.3. 0.3 repeated m cubed, right? This is volume, so you have to label your units. Okay, something like number 5. Obviously, we don't need the diameter, but the diameter does give us a radius of 3.2. And then we know that the volume is 4/3 pi r cubed. So we know that the volume is 4 divided by 3 times 3.14 times 3.2 cubed. Okay, so using your calculator, you definitely want to calculate 3.2 cubed first because that follows the order of operations. Then you want to multiply it by 3.14, which is pi, and then multiply it by 4 and divide it by 3. I'm getting 137.2. And you want to be careful with your calculation here. You want to make sure that you didn't enter something incorrectly. And also you want to box your answer. Okay. Every time you plug in, this is the work I need to see, right? You know the formula. Like this is what I'm looking for when I look at your homework. I know that you're using a radius. That's correct. Not the diameter. I know that you know the formula. And then I want to see you plug it in. Show me what you're actually plugging into the variable and the pi symbol. And then finally, obviously, that's when you use the calculator, and then you just give me your final answer. Okay, let's shift gears to something a little bit more complicated. This is when we have two shapes in one, right? And this is when we have a cylinder combined plus a hemisphere. So I talked about what a hemisphere is briefly before. A hemisphere is just half of a sphere, and I'm going to write down the formulas for both, right? The volume of a cylinder is going to be pi r squared h. We know that. We know that from 5.2a lesson. So since a hemisphere is half of a sphere, then we know that it's not 4/3 pi r cubed. It's exactly half of that, which is 2/3 pi r cubed. Okay. Now, you also want to write down any details about the cylinder that you know. So I'm going to write the radius of the cylinder is going to be 15 cm. And we also know that the height of the cylinder is going to be 30 cm. Okay. In terms of the hemisphere, the only thing I need to know about it is that it has a radius of 15 cm. And once you lay out all the known information, you then have the opportunity to plug in, right? So the volume here is going to be 3.14 times 15 squared times 30 for my cylinder. And for my hemisphere, I know that it's 2/3 times 3.14 times 15 cubed. Okay. And now this is just a calculation that you need to do. So always start with the exponent because that's the order of operations. So I'm getting 15 squared, which is 225, times 3.14, which is 706.5, times 30. And I'm getting 21,195. That's a big number, but did I miscalculate something? Oh, wait. That's kind of confusing. Wait, it says a hemisphere with a radius of 1.3 yards. I'm not too sure why they gave us something in centimeters and then the hemisphere has yards. I think the objective was for us to calculate the total volume in centimeters. So I'm a little confused as to why they gave us that the radius was 1.3 yards. But I'll take a look at that after. I'm getting 21,195, and I'm going to just write that down for now. In terms of the volume of the hemisphere, let's calculate that really quickly. 15 cubed is 3,375 times 3.14. Then times, I'm going to write 0.666, which is 7,064. And I'm getting 7,064.99. And obviously, we have to add these two values. So now I'm going to add the 21195 from the cylinder. And my overall volume, right? Overall volume is going to be approximately 28260 centimeters cubed. I used the concept that we had a radius of 15 for the cylinder and the hemisphere. I know it says that we have a radius of 1.3, but I would just use the 15 for this calculation because I want the answer in centimeters. Okay. Let's try one more problem. The sphere below fits perfectly into a cube. The cube has a volume of 64 feet cubed. Find the volume of the sphere. So we know that a cube has the same dimensions for all three of its width, length, and depth, right? And the fact that the volume of the cube is always going to be s cubed, right? That's why we call it cubed. The fact that it equals 64 tells us that the side length has to be what number? It has to be 4, right? It has to be 4 feet. Okay. So we know that each side length is 4. And then we also know that a sphere fits perfectly inside here, right? And that tells us that the sphere has a diameter of 4. But realistically, if the sphere has a diameter of 4, then doesn't that mean the radius of the sphere has to be 2 feet? Right? And then if the radius of the sphere is 2 feet, that's enough information for us to calculate the volume of the sphere. Remember, this is the formula, 4/3 pi r cubed, which ends up being 4/3 times 3.14 times 2 cubed. And then we just leave that to the calculator. We get 8 times 3.14. Make sure you enter things correctly. Times 4 divided by 3, approximately 33.5 feet cubed is the volume of the sphere. Okay, I think this is a perfect time to stop. Please ask questions in class. I know you may have a lot of questions, and we will definitely do some more practice right after this. Thanks for watching.